What's up, everybody? So a lot of people like the video on using cursor and large language models to, um, make red team tools. The one I did the other day, I made a process injection based on Hollow by Whoami Code. Today, what I'm going to walk through is called Pool Party. And we're going to go through the first variant. There's a bunch of them, but we're just going to go through the first one, again, starting with that one because I think it's the most simple and straightforward, and I can squeeze it into a video. So I've already gone ahead and set up some stuff for this so that, for the sake of time, you're not watching me just go through and kind of set up my project here. But we're going to do it in Rust. And first, I'll show you the blog, and I'll link this in the replies. But so what we're doing is this pool party technique from this Safe Breach blog article. And basically what I've done already is I've gone through and read the blog, and you can see that, it explains some of the logic and also specifies some of the API calls that we'll be using for this. And, specifies a bunch of the API calls and stuff we'll be using. Then I also went and found the GitHub repo that they put out with this and identified the main logic here in Pool Party. You can see there's a function here called inject, which, steps through a bunch of other functions, and we can sort of follow the logic and implement it, re-implement it ourselves in our Rust program, which I'm going to build as a crate, a library, so that you can call it from other tools. So as I said, you can see right away that if we look at, okay, first step is get target process handle. If we click on that, we can see that it's using open process, and we can see the parameters that they're using with that. So that's kind of how I've gone through and identified what operations I need to perform. So I've set up my Rust project. This is shellcode for popping calc. I took it from another one of my tools, so I know it's good. You can see here I've set it up to get a target process ID from on the command line and set up some error handling so that if the user doesn't pass an argument, a PID, then we'll exit the program and let them know that. And then I'm calling my wrapper function, which is in my library. And you can see right here, all it does is call party time, which is our private function that's going to do the same thing as their inject function right in here. Okay. Now, again, for the sake of time for this video, I've already gone and identified all of the imports that I'll need to accomplish this. So again, if you're not familiar with Rust, you can import other libraries easily. And for the sake of a POC, I'm just going to be using the WinAPI NT API crates, which I've defined in my cargo file already, along with some of the features that I need. As I always say, I always do a proof of concept version, and then you can always go back later and modify it for additional OPSEC considerations. Usually what I'll do is I'll make the first version using these imports, and then I'll go back later and I'll change it to do dynamic resolution of APIs, or you could use syscalls, unhooking, whatever you want to add evasion techniques later. But first, we just want to get it working. So we're just going to use these crates that are available. And just to give you an idea, if we look up Rust NT API and we go to the docs, this is how I always go through and find what I need. So, you know, if I go in here and I look for NT query information worker factory, right? It tells me, you know, where that function is. You can click on that to copy, and then you can come in here and say use that function and import it. And now that function is available to be called in your program. And I've already got it here, so I'm not going to re-import it. But that's how I went through and identified all of these imports that I need. Some of them are API calls, some of them are types, and the types are based on, you know, what the API calls require. So didn't take very long. It looks like it probably would, but you get used to it in Rust, and it doesn't take very long to identify what you need and just import it. But we're going to go ahead and get going here. First thing I always do too is I want to make sure that my structure is sound. I've got everything set up the way I think I want it, but I want to make sure it's sound. So I've got just a hello world in here right now. So we're just going to test first and make sure that that runs fine. We'll try it without a PID, make sure our error handling is correct. And you can see, yeah, it says you need to include a target process ID. All these errors are just for, or warnings rather, are just for unused libraries and variables and stuff because of all of our unused imports. But we're going to need them later, and by the time we get done, there won't be any warnings. But it did, you know, work the way we expected. Now I'll test it out with a target process ID, which I've already opened a notepad to target here. So it's 12676. So we'll put that in. And you can see it prints hello world. So our structure is sound, and we should be good to go to start implementing our actual functionality. So I'm going to comment that out, and we'll start working through our logic here. I know the first thing that I need, again, based on the example code that we have, is to get the target process handle, and looking at that, where'd it go? Yeah, looking at that, I'm just using the same. I'm just going to use the same parameters that they're using here. I know that it's going to use open process, so we'll go ahead and implement that. So what we're going to do here to keep everything clean, and you can see, like, I'm using Cursor again with Claude Sonnet 3.5. You can see here it's already trying to predict like what I need to do. But that's not going to be exactly correct, right? Because it's using process all access. We're not going to do that. So we'll, make some modifications, but it's kind of cool. It's already trying to figure out, what we're going to do. I will tab this just to get the some of this, this function structure, which looks all right together. And let's see. Right, but we want to make modifications here. First of all, I think, yeah, this needs an unsafe tag. Okay. And then we don't want process all access. We're going to use the same flags that they use. So I'm just going to copy those and get rid of process all access. Boom. I've already imported them up top, right? So now they're not, they don't have this squiggly line to let us know that they're not being used, because now they're being used. So that's cool. Here, Cursor guessed that this needed to be false, which it does if it's in C, but in our case, this needs to be a 0 actually. Just a little bit of a difference there between the C and Rust in this case. And our PID is going to be a U32. Again, just a little bit of a difference between calling open process in Rust from this when API crate, which is where we're getting it from, versus doing it in C++ like our example. So yeah, I think that's from the when API crate, right? Yeah, okay. Yeah, we're using when API. All right, so that looks like, good. That should go ahead and return our handle, right? So pretty simple, open process, got our flags, inherit handle false, and our PID, which we've already passed on the command line. So we will save this and run it and see if we get a handle to the process. And you can see that we got a handle. Good. So step 1 is complete. If we go back to our example, the next step is hijack handles. And if we go look at that, we can see that it's doing a couple things here. No, that's not the exact one we want. I don't think. Hijacked handles. So I think this is actually a handle hijacker. Yeah. Yes. So this is where I got a little tripped up reading through this because they don't specify in the write-up. They specify using duplicate handle, but they did not specify. So we already have a handle to our process. What we need now is a handle to the worker factory, which is a little bit different. It's not the same. And without going into that too much, they just say they use duplicate handle. You can read the blog and understand why, but they didn't specify how they were using duplicate handle and what other calls they might be making, but it is in the code. And we could see that they were using NT query information process, and then using duplicate handle after that. So that gives us a little more information. So we are going to make a function called find worker factory handle. And it's already trying to give us some information here, but it's going to mess up because like the article talks about NT query information worker factory, which is what I thought we originally needed. But what we're actually going to do is use NT query information process. So I'm going to get rid of that. And what I could do here, just to show you, is I can pull up chat and I can say, I can take this, copy this function that they're using to get the worker handle and talk to Claude about it and say, so need to get a handle to the worker factory. I have a working example in C++. Please take a look. And then let's implement the same functionality in Rust. We'll see what it comes up with. This might take a second because, it's a pretty complex request. And I don't have fast requests on because they get expensive. All right, so it says I'll help you. So let's see what it's got here. Okay, so this time, since I gave it the example, it correctly identified that we need to use NT query information process. It knows that we're going to pass our process handle. We just got to it. This all looks fairly good. We might make some changes to how some of the casting is done with these types, but this looks pretty good. Then we iterate through the handles. Using get current process. Is that how? Well, this is going to be a little bit different than how I want to do it. So, you know, this will get you started. This gets you pretty close, right? But this is going to be a little bit different. This is the toughest part of this tool, in my opinion. So I'm going to give it a little bit of help here for the sake of time. But you know, this is fairly close. So I will apply this, and then we'll make our own modifications here, because I already know some of the issues we're going to run into. But I'm interested to see, though, to compare type, match not found. For now, just return the first valid handle. It needs to be updated. Yeah, see, it kind of phoned it in on this one. It didn't like do everything, and I'd have to tell it like, hey, you need to implement everything and all this stuff. For the sake of time, I'm not going to go through all that right now, but I'm just going to show you some of the changes that we would need to make to this. So first thing I know is that we're going to run into some issues with the buffer size potentially. So the workaround that I set up for this is going to be a usize. So this is probably not ideal, but this is the way that we're going to do it for now to get around an issue that I know we're going to run into. And that's the like buffer not being large enough when we go to iterate over the handle info. So we're going to also change this. I'm going to use a macro here, and that's close, but we want to specify here that this is a U8, and then our buffer size, that's good. Return length looks good. Okay. As I said, I'm going to make some changes here as well. So it's casting as a p void. You know, that might be correct. Let me see. Yeah, this is the process information class. Yeah, that looks good. But we're just going to use this, which is like a little trick where it's just going to cast it as, you know, whatever type that it's supposed to be. And that all looks good. Now I want to print some stuff since we're like working through it. So I want to print the status of this request, and I want to see if our return length makes sense, because I know that was an issue before when I tried this. So we're going to, you know, go ahead and print that status. Okay. I don't really like that. So I want to return a result here with an NT status in case we have an error, instead of just returning a null handle, because that's not going to help us out. That's just going to mess up our program. You know, if we keep going and try to use that null handle. So instead, if our handle, if we're not successful, we're going to return an error and return the status. That's part of our unsafe block. Okay, I don't think we need that. And now this is the part that iterate through handles. This is the part that it got wrong. And I worked through this already, so I already have a solution. But rather than walk you through all of that, I'm just going to go ahead and start implementing my solution here. So cannot find process handle info in this scope. Let's see why we don't have that. Oh, right. Yeah. See, this is why I said this was one of the harder things to implement. So, yeah, we're actually going to set up a couple types ourselves here. And I forgot to do this. So we're just going to drop them right here. Boom. That's what, it was missing this type. So now we have that type. This is probably missing an unsafe block. When you do fun things in Rust, you have to put an unsafe block on it. Add unsafe block. There we go. Okay. And I apologize for this part. You're not getting a ton of information because it would take a while to like go through the debugging process for this one portion, but we're going to start speeding up here pretty quickly after this. So bear with me. So we got our handle snapshot, handle entry, duplicate a handle, let dupe result. Okay, so here's where we need to change this. So we're going to get rid of that. And it'll probably figure out what we need there. Yeah, so I can just tab complete that. And then we're going to change this to use get current process. Bingo. That looks pretty good. Duplicate same access. Okay. And this is where it kind of phoned it in. And like I said, for the sake of time, I'm not going to drag you through all of what I had to do in this particular function. So I'm just going to give it some help here, and we're just going to give it the rest of this function and get on to the rest. Unsafe block. Yes, another unsafe block, I'm sure. Yeah. And just add all of our unsafe blocks. Okay, and we had an extra bracket. All right. So, like I said, this was a little complicated, but basically what we're doing is we're calling NT query information process, and then we are iterating over the handles and then identifying the handle that we want and duplicating it. While we're duplicating handles, and then we're checking to see if it's the one that we need based on this TP worker factory. If it is, we keep it. If not, we close it out and we don't use it. Let's see if this is working. Oh, I don't even think I called it yet. I didn't call it yet. Okay. So obviously this is not being called. We need to call this function. I tab complete that. Boom. And now we should get the handle to the worker factory. And we kind of do, but we saved the result to this variable instead. See this? Because I wanted to return a result in case we had an error, which is great, except for now we're capturing the result in our variable instead of the handle itself, which is not what I want going forward. So we're going to make a slight change to this as well. And this is why you need to know what you're doing. When you're using AI, because it can get hung up on stuff like this. So let's see. I don't want to do that. Here, I will tell it instead. I'll tell the AI to do this. Okay, so I'll say, hey, instead of capturing the result of our function here, I just want to capture the handle in worker factory handle and then print it. please make this change. We'll see what it comes up with. Hopefully it'll give us some decent error handling too. It did not. Okay, it just gave us an unwrap. Well, if it's messed up, then the unwrap is going to panic. So I don't know why I did that. I have to complain. Don't just use unwrap. Use unwrap or else and handle the error. So you have to be really direct with AI. Again, you have to know what you're doing. Otherwise, you'll be like, oh, this looks good, and then put it in there, and then you're going to panic when it doesn't work. So you have to know what you're doing, and still, it's not, vibe coding. We're not doing that. We know what we want. We're just having it do it for us. So now it did it. It's using unwrap or else. I will apply that. Accept. So now it's using unwrap or else. So if it tries to unwrap and for whatever reason it doesn't work, then it's going to give us a panic with a specific error and status. Otherwise, we get our handle that we want captured in the variable instead of the result. So let's take a look at that. Okay, cool. And you can see now that we have our process handle. We can see that, everything looks good here. And then we're getting back our worker factory handle. And I'm actually going to kill some of those other print statements because I don't care about them now that the stuff is working. So, making progress. We've got a process handle. We got a worker factory handle. Awesome. Worker factory handle is what we need. Now, if we go back to our example, let's just go to myself. Go to inject. I'll try to make this a little bigger for you so you can see what I'm looking at. Okay, so we got the target process handle. We've implemented hijack handles in order to identify and grab a handle to the worker factory, which is actually what we need. And now the next step would be to allocate shellcode memory for some of the variants of pool party. But for this variant that we're doing, which is the first one, we're doing the first variant. We don't actually need to allocate memory ourselves because what we're actually going to do is we are going to overwrite. The first variant is based on overwriting the start routine. I think it is the start routine content with our malicious shellcode. See? So the first variant is based on overwriting the start routine, which is part of the worker factory basic information, which is why we need a worker factory handle, right? So instead of allocating memory in the remote process, we are going to find the address of this start routine, and we're going to write our shellcode to that address. We're going to overwrite that address. Okay. So in order to do that, the next thing we need to do is get that, get the address, right? So instead of allocating shellcode, we're going to get the address. So next function we're going to make is going to be get worker. That's not bad. But I actually want to name it a little different. Factory basic info instead of information. Just keep it a little shorter. Okay, so it thinks that we need the worker factory. Oh, I lost it. All right, so it thinks we need worker factory handle, which we do, and we're going to return a result, which that looks good. So we'll tab through this, and then we're going to make changes because this is not going to be exactly right. I can already tell. So, you know, I don't know what it's trying to do here, but I do know worker factory basic information. I already, this is what we want, right? Because this is, yeah, this is the actual struct that we want here for our result. So I'm going to fix that. Boom. That should be right. And then NT status, that's fine. Okay, it doesn't like that. Oh, is that because of what is in here already? Probably. What does it not like? Oh, because there's no return expression. Well, there's gonna be. So let's put in here, just to get us moving in the right direction, we'll put an OK basic info. Yeah, and then yes, we do. So that looks good. That looks good. It's zeroed out version of worker factory basic information. Why is it not? Okay, we'll just do this. Boom. Okay. And this, you can see how it's already trying to suggest stuff now based on, you know, it has more information now of how I actually want, the struct I actually want. Now it has a better understanding, so it's trying to give us, the rest here. But we're going to return an NT status, so we don't need, like, see how it was trying to do a return length and stuff, but we know we're going to return an NT status. That's what I want, so we're not going to do that. So we're going to go down and we're going to say let status, and you can see it's already figuring out. It's like, oh, okay, that's fine. We'll just do it that way. So now it says NT query information worker factory, which is what we want. Has our, let's tab that, see what's up. So tab, and we got some errors here, but that's okay. So let's see. So we're using NT query information worker factory, which is what I've already identified we need for this operation. So that's cool. We are passing it a worker factory handle, which we got previously, and we're passing to this operation, right? Then worker info class 7. That should be correct. This part needs to be cast differently, I believe. So let's see what the error says. It says expected raw pointer C void found mutable reference to this struct. So this is something that the AI should be able to fix for us. I'm going to copy the compiler diagnostic message. I'm going to paste it into chat. I'm going to say address this error. And it should be able to figure this out. It just needs to cast it to a C void. I don't think it'll have any issue with this, but we'll see. All right. Still trying to add a return length, even though I don't want that, don't care about that. I don't know why. I might have to tell it to stop doing that. But you can see here where it is now casting it as a raw pointer. But I'm not going to accept all of this because I don't care about this return length, frankly. Okay. So actually, you know what? Here's what we'll do. We'll hit apply because this is pretty clean. Okay. Boom. So that's fine right now, but like, why are we creating this variable for absolutely no reason, right? When we could just do that and have a standard pointer null nut, right? Like, no reason to create a variable just for a null value, I think. So there we go. So that, that was okay. This is a little more challenging for the AI than most, a lot of stuff that you might work on, but we're getting there. So now we need to call this function. So we got our process handle, we got our worker factory handle. Now we're going to get the basic information about that. And we got the info. Okay. So instead of printing the whole info, we don't need to do that. What we need is we want to know where the start routine is. So we're going to do basic info dot start routine. I think that should be right. What's the problem? Cannot find. Oh, okay. Yeah, worker factory basic info. All right. So we're just, this is a struct, and it has fields, and the field that we want is the start routine, right? We know that from our blog here. So it's the worker factory basic information struct. We're interested in the start routine. Oh yeah, class 7. Yeah, that's where I got that. So we're interested in the start routine. So instead of printing the whole thing, which, you can't print the whole struct anyway without doing some nonsense. But we don't really care. We just want to know if we have the start routine, because that's the address that we want to overwrite. So let's see if we got it. All right, cool. That looks like a good address. So we got a process handle. We got our worker factory handle. We have the address of the start routine that we want to overwrite with our shellcode. Okay. So next step, we want to write shellcode to the existing start routine address. You know what though? I mean, this looks good, but we're gonna grab all this. We're not gonna do this. Sorry. I want to keep it clean. I'm gonna make a new function for this. Function write shellcode to memory. Boom, boom. I'm just hitting tab a bunch here. What does it not like? So we have a let status, and this returns. Oh, this returns a boolean. Okay. So instead of NT success and all that, we're going to do if write result equals 0. Because I think, oh, yeah. Okay. Yeah, so I think that should return a non-zero if it's successful. So it'll return, yeah. So if it returns a 0, we know it failed, because it returns a boolean. Okay, so let's see. It's doing write process memory. It has the target process handle. It has the start routine address. And I'm going to double check these types here. And I don't want to do p void. I'm going to keep it simple. Yeah, and do c void. And for shellcode, that should be fine. Process handle, that should be fine. Result NT status, that's cool. And then start routine address. Yeah, this is a mutt c void now. Good. That way we don't have to like worry about any issues with the Rust imports and differences that could exist between different libraries with like C void and P void and all this crap. So we're just going to keep it consistent. We already have this captured, I believe, as a C void. Up here, I think that's what it's going to be. Yeah. Yeah. So this is already going to be a C void. Yeah. So that's what we want there. Shellcode is pointer as constant C void. I believe that's what we want. And then size T for the shellcode length. That's cool. And then null. Yeah, this looks pretty good. So now let's go up, and here's where we were going to call it. Yeah, why did it set it up that way? I don't like that. All right, well, let's grab the compiler diagnostic and tell the AI to fix it. I think it should be able to. I don't feel like dealing with it. Address this error. Is that true? Is that what I need to do? I'm not sure about this. Just looking at my notes real quick. I don't think we need to mess with this function. I think we just need to make a change up here. But I mean, what it's doing will probably work. So let's try it, because I think what it's doing will work. It's not maybe the way I would have done it, but I think it's going to work. So yeah. Okay. So instead of getting, well, I don't know. I guess it's not really that worth getting into, but I was going to change it up here to match our function, but instead it modified the function to match what we had where we were calling it. You know, it doesn't really either way, as long as they match, right? As long as the colon code matches the function signature, like either way, right? So this should be good. And then let's print something here. Just to give us the warm fuzzies. Boop. All right. So this all looks good. No errors. Looks pretty good. Okay. Back to our example. So we did not do the allocate memory because we're going to instead overwrite the start routine. We found the start routine. We wrote shellcode to it. There's one step left, set up execution. And this gets crazy again. Okay. You have to remember too, like when we're looking at this, this is written for a bunch of different variations. But we're only doing one. So we don't need to worry about some of this stuff, right? So I'll talk to you about my solution here. So what we are going to do is we want to increase the thread count to trigger our execution. All right. So what we're going to use is NT set information worker factory. Here, I think they probably reference this in the blog. Let me go see. Yeah, here it is. Okay. So as I said, the start routine is guaranteed to run at some point, but it'd be better if we could trigger it. So we've already kind of got our process injection in place. Hopefully it doesn't go off while we're sitting here. But we want to trigger it. So what they identified for this was NT set information worker factory. This call supports, some more information classes, and the one that suits our needs is this thread minimum here. And so by setting the minimum worker threads number to be the current threads plus 1 results in a new worker thread being created and executing start routine. And you can read more about this here. But once we've accomplished this, we'll be all set. Now, what I'm interested to see is if I feed this blog about this part to the AI, maybe with the code example, like, will it do this for us, right? So let's say so we want to increase the minimum thread count to trigger execution. And then I'm going to go in here and say, look at this blog post, which indicates how we are triggering the shellcode execution now that we overwrote the start routine address. It uses, what was it? NT set information worker factory. NT set information worker factory. Can you implement this into a new function in our program called setup execution? Now, the reason I'm like showing you this and trying to do it this way is to show you that how using AI, using something like Cursor, and having like a blog that explains a technique, you can walk through the logic in the blog, show the blog to the AI, and build a tool. So let's see what it says about this. All right, so it says that it understands. Okay. So it says, based on the blog post, we need to use NT set information worker factory with the worker factory thread minimum information class. I think that all checks out, right? Yep. So it read the blog, correctly identified that information. Now let's look at what it's actually doing. So its plan is, this is incorrect, okay? Because in the blog, we can see that they specify that we need to set it to the running threads number +1. It messed up, and it wants to set it to just 1. First of all, I'm going to apply this because we're going to use most of it. I just want to get rid of white space there. Okay. That's fine. That looks fine. Okay. Accept file. All right. So it looks okay at a glance, but again, if you don't know what you're doing and you haven't understood the blog, then you're going to think that this is fine because the AI said so, when really there's an issue here, right? It has assigned the minimum thread count to 1, but in our blog, we know that we want the number of running threads, to the total worker count +1, which is not the same, right? So, and it's only passing the handle. So, okay. So let's talk to it about that. Okay, that's pretty close, but I noticed in the blog that they don't set the min thread count to 1. They set it to the current thread count +1. I believe we can get the total worker count from our basic, what do we call it? It's not basic info. It's worker factory basic info struct. That we gathered earlier. Can you make this change, please? You should probably say please too, because one day the machines are going to take over and they're going to remember if you're mean to them. All right, so I think it'll probably be good after this. I think it'll be able to understand that and help us out so we don't have to manually do it. I mean, it's not a big change, but okay, so it's a little confused. It didn't look at the whole context because it wants to go and get, it wants to re-get that information instead of realizing like we already have that information and we can just pass it to this function. It wants to redo that. So it didn't read our whole file or something. I don't know. Sometimes this happens. Again, you have to know what you're doing. You have to pay attention. You have to catch its mistakes. So we're going to help it out here. And we're going to change this so that we're not just passing a handle. We can also pass the basic info. And it starts to figure it out right away, right? It's like, oh, okay. Also, it's giving me an NT. Why does it keep doing NT status? Like, can I get some results? Anyway, we'll fix that in a minute. Okay. So now it knows that we want to pass this additional information. So I can tab complete this now. And now we're going to have that struct from earlier that we need. Okay. So, and then now it's doing thread count. I don't think that's correct. Yeah, there is no field thread count. Okay. I wonder if it shows us all the now 19 others. That's not very helpful. Is this referenced in the blog? Don't see it. Yeah, see, this is where, yeah, see, they snipped this out, right? They're not showing everything that's in there. Trying to think of a simple way that we could. see this. All right. If we go look this up, go look at the struct, see what fields it actually has. Okay. You can see the fields that it actually has. It doesn't have the field that it wanted, which is thread count, but it does have something we can use. Here we go. Total worker count. All right. So this should be what they reference here, running threads number. Okay. Total worker count should be the total number of threads. So we're going to use that instead. Let me double check this. Total worker count. Okay. So let's just go ahead and change that. Total worker count plus 1. Total, you stinker. Total worker count. See, AI is very good, very useful. A lot of times you can just tab complete, but sometimes like it just, I don't know, it wasn't referencing the docs. Now we could tell it to figure this out, right? We could have said, hey, there's no total threads. Here, let's see what it says. Hey, there's no total threads field on. Here's how you could figure it out with AI. I'll show you. So you could say, hey, that field doesn't exist on that struct. Check the docs and see if there is a field that will work for our purposes of incrementing the total number of threads or workers. And then we'll give it the link to the docs. Boom. And I'm going to actually take this out because I want it to try to figure this out. And we'll see what it says. I think it should figure it out, though. And that's how you would figure it out if you didn't know, okay, and you couldn't tell by yourself from reading the docs. This is what you could do. You could tell it, hey, that field doesn't exist, but why don't you go reference the actual docs, read the documentation, and tell me which field will work? And there we go. It figures it out. And now it figured out that we already had the basic info from earlier, and we don't need to redo that part. So that's kind of funny. Okay, so if we accept that, and then have we called this yet? I doubt it. Yeah, I guess we did. Okay. So I think we're done, right? That should be it, because if we look back at the blog, yep, we have now done that. We are using NT set information worker factory to increment that count. And according to the blog, we're done. And if we look at the example, the last thing that's done in setup execution is, or in inject is setup execution. So, and like I said, if we look at setup execution, oh, here it is. Oh, I missed it in the code earlier. I was looking in the wrong area. I could have just looked at this and saw exactly what we just figured out, total worker count. And if I had fed it this example again, it probably would have figured it out. But anyway, we got there one way or another. So let's try it out. And I'll just show you that we have our notepad running. Uh-oh. Failed to find worker factory handle. What changed? 67. So this is an issue where I'm concerned that I wasn't paying attention, and when I accepted some changes earlier, you know what? Let's try it with a new process because we messed with this process already, and I want to make sure that's not our issue. Oh, that is our issue. Okay. Yeah, it's because we kind of injected that other one already before we did the final step to set up the execution, and it kind of hollowed out that process, and then it relaunched with a different PID. I think that's what happened. Let's just try it again, and then you know what? I'm just going to kill this process because I think that's what's going on. Oh, shit. Uh-oh. I done goofed. Okay. Yeah, I think that's what's going on. Is that we messed up that process with some of our previous testing. So let's just try again before we get concerned. Bingo. We got a calculator. And our notepad process is, it's gonzo. It's gone. All right. So you can see we got a process handle, worker factory handle, the start routine address. That's what that should say. I'm going to go fix that because that's misleading. Start routine address. And we got a calculator. Let's try it again. Just because it's cool and badass. 17784. So let's. Boom. Calc, right? All right. So we're done. That took longer than I hoped, I think. Let me take a look at where we're at on time. Yeah, it took an hour. Thanks. Okay. Yeah, I mean, this one's more complex than obviously the hollow process injection the other day. And sorry, I kind of skipped through a little bit of it. I knew it was going to take a while, and we would have been here a lot longer if I hadn't kind of skipped through some stuff. But I hope that the stuff I did show you working with the AI kind of gives you an idea of how you can talk to it, how you can ask it questions, how you can ask it to fix stuff, and how you can like take a blog and walk through the logic. And if you understand what's going on, how you can then leverage AI to help you implement a tool from scratch. All right. Now, I might chop this up and condense it down, but usually I do release raw videos. So I'm sorry, it's an hour long. Put it on 2 times, 3 times, 4 times, whatever. But I hope you got something out of it. Cheers.